All right, in this lesson, we are going to talk about properties of log. And so these properties come directly from their associated properties of exponents. And so quick recap of our exponent rules. If we are multiplying two exponential expressions with the same base, we add their exponents. If we are dividing, we subtract the bottom exponent from the top. And then if we have two exponents on one base, we multiply those exponents. Okay, and so remembering that log is giving you an exponent, it's kind of like this is going in reverse. So here we were multiplying and our associated property was adding. Here we're multiplying and our associated property is going to be adding. So log base b of u plus log base b of v. So we can break this u and v product up into their own individual logs, and then we break them apart with a plus sign. Here we have division, and so when we break them up into their own individual logs, we are going to subtract. Okay, and so division still goes with subtraction. Multiplication still goes with addition. And here, if you have an exponent inside your log, that exponent comes down to be multiplied. And you can actually prove each of these properties by using the laws of exponents, but we won't get into that. But for now, you just need to memorize these three properties because that's how we are going to go from our condensed form. Condensed form means you only have one log and everything is inside, and we are going to convert it to our expanded form where we have multiple logs and only one argument per log. Okay, so in this next set of examples, we are going to expand. Okay, and so right now we have all the condensed versions. We only see log written one time, and so we're going to break them up into their own log. And so you kind of want to think one argument per log. One argument per log. Okay, and so here I've got log of 7x. Those are being multiplied, and so I'm going to break them up using addition. Log 7 plus log of x. Same base. So keep that 3 every time. And that would be the expanded form. And I know I'm done because each log only has one input. 7 for the first, x for the second. Okay, here we've got more going on and we're working with natural log. And so first thing I'm going to do is break apart these products. So natural log of 4 plus natural log of x squared plus natural log of y to the 5th. Okay, we're almost done, but the x squared and x5, those exponents can't stay inside. And so now we're going to use the property where those exponents come outside as a multiplier. Okay, and so this would be our final answer where there's only one argument and it's not being raised to an exponent. All right, this next example, there's a lot going on. So the first thing I want to do is break it apart because it's division. And so I'm going to have the 3x squared inside its own log minus the log of 2y. Okay, and so break apart that fraction first, and then now we can break apart the products. So we have log 3 plus log of x squared. And then notice that the 2y, they're both inside a negative log. We're going to have to preserve that. So log of 2 minus log of y. You can also think of it as you have that minus log of 2y, and so minus log of 2 plus log of y. And so then you would just distribute that negative. And so your final answer would have log of 3 plus, and we have log of x squared. And so remember, when you have an exponent, that exponent needs to come to the front. And then we are going to distribute the negative so that we don't have extra parentheses. Okay, and so I want to give you a trick to how you could skip to this last step. Is when you see a fraction, anything on bottom is going to be inside a negative log. Anything on top is going to be inside of a positive log. And so you could immediately jump to log 3 plus log x squared, those are in positive logs, minus log 2 minus log y. And then your only remaining step would be to bring the 2 down. And you're going to start to be able to do that in the same step as well. The less steps you take, the less confusing it gets. I don't usually say that about math. I usually say take all the steps, but honestly, it's harder if you try to break them up into too many steps. Okay, looking at number 4, that fourth root, that is actually an exponent of 1/4. So go ahead and rewrite that in its exponential form. And then using our properties of exponents, we have 2 exponents on one base. So we need to multiply those exponents. Okay, and so that would be 5/4. And so now the only thing left to do is to bring that 5/4 out front. So now it's 5/4 log base 3 of x. Okay, here I see a cube root. So the first thing I'm going to do is rewrite that as x over y to the 7th to the 1/3 power. Okay, and then next there's 2 things you could do here. One, you could go ahead and bring that 1/3 to the front, or you can distribute it inside the parentheses. And so really this would be log 2 x to the 1/3 over y to the 7/3. And then now when we break them up, we have division. So we have log of x to the 1/3 minus log of y to the 7/3. And then we can bring those exponents down. So 1/3 log of x minus, keep forgetting the base of 2, don't forget that, 7/3 log base 2 of y. Make sure there's only one argument and no exponents inside the log. All right, this last one looks kind of tricky. And so this is natural log. I see a square root. And so the first thing I'm going to do is rewrite that square root as a 1/2 power. And then I'm going to break those apart. So I have 4x plus 1 to the 1/2 power. And then it's going to be minus natural log of 8 minus natural log of y. Those are both on bottom, so they're each going to be inside a negative log. Okay, and so now focusing on this 1/2, we know that needs to come out front. And then be very, very careful with what we're left with. We do not have a property for when we are adding inside of a log. You cannot break those apart into their own individual log. We only have properties for when we are multiplying, dividing, or raising to an exponent. And so if you have addition inside the log, that stays. You can't do anything with that. So this is actually our simplified final answer. All right, in these next examples, we're going in the opposite directions. So we are going to condense, okay? So everything inside one log, everything inside. Okay, and so here in this first example, we are subtracting. So when I write them in this inside the same log, we're going to have a division bar. Okay, here we are adding, and we also have a 2 as a multiplier. So So before I do anything, I'm going to go ahead and move that 2 inside the log. Everything needs to go inside the log. So that 2 is the exponent. Okay, and so now that addition is going to turn into multiplication inside the log. And because these are just numbers, we do want to go ahead and simplify that. So that's going to be 6 times 9, which we know is 54. So your final answer would be log base 8 of 54. Okay, this next one, the first thing I want to do is put everything inside the logs. And so this 2 needs to go inside, this 1/3 needs to go inside. And so when they're inside, those become the exponents. And then to simplify, 1/2 squared is just 1/4. And then I'm going to leave that as 1/3, even though we know that's cube root. If we needed to, we could convert that if it was like a multiple choice test. And so now I have plus signs. So all of these are getting multiplied inside the log. And so 40 times 1/4 is just 10. And so my final answer would be natural log of 10 x to the 1/3. If you wanted to, you could convert it to cube root, but typically we stay with exponents because logs and exponents go together. But say if this was like an SAT question, multiple choice, this would be equivalent. And so I wanted to go ahead and write that down. Okay, here, this 3 is the exponent of the x, this 2 is the exponent of the y, this 2/3 is the exponent of the z. Okay, next, x cubed is inside a positive log. Y squared is inside a negative log. That means he's on bottom. Z to the 2/3 is inside a positive log, so he is going on top. So whenever you have negative and positive logs, only make one fraction. You don't want a triple layer fraction in here. That would not be fully simplified. And so anything inside a positive log gets written on top of your one fraction bar. Anything inside a negative log would be on bottom of your one fraction bar. You only get one fraction bar. Okay, here, if you have a set of parentheses, go ahead and distribute that multiplier to each log inside. So that would be minus 2 log of x, and then minus 2/3 log y. I like to do the parentheses to really see what's inside versus outside. And so I distributed a -2. So -2, -2/3. That's why I have minus signs now. Now, because I'm seeing some multipliers, I'm going to go ahead and put those inside their respective logs, keeping the minus sign outside. And so I have log of 5 minus log of x squared minus log of y to the 2/3. Okay, because I see some negative logs, I'm going to go ahead and put my 1 log in my 1 fraction bar. The 5 is positive inside a positive log. The x squared is inside a negative log. The y to the 2/3 is inside a negative log. And so that would be our final answer. 1 log, everything inside. Okay, on this next example, we are distributing a 2/3 to each log. So 2/3 natural log of a minus 4/3, 2/3 times -2, natural log of b minus 2/3 natural log of c. Just distributing that 2/3 to the parentheses. Now each of those 2/3 or those multipliers need to go inside as the exponents. Leave the minus signs outside. We'll take care of those next. So natural log of a to the 2/3 minus natural log of b to the 4/3 minus natural log of c to the 2/3. Okay, So now we're ready for our 1 log and our 1 fraction bar. That gives me a to the 2/3 on top since he's inside a positive log. The b and the c are both inside a negative, so I have b to the 4/3, c to the 2/3 on bottom. And that would be my final answer. All right, these last examples are very similar to how they ask log questions on the SAT. And so they're giving me that log of some base of 2 is equal to a 5. And they're also telling me log base b of 3 is 7. So anytime we see log base b of 3, we're going to replace it with a 7. Anytime we see log base b of 2, we're going to replace it with a 5. And so they're asking me what log base b of 18 is. And so what you want to do is rewrite 18 in terms of 2s and 3s. So 18, if I just make a factor tree, is 2 and 9, 3 and 3. So 18 is the same thing as 2 times 3 times 3. And then I can break them up into their own individual logs by using addition. And then now, every time I see log base b of 3, I know that's 7. Every time I see log base b of 2, I know that is 5. That's what was given to us. And so we can add those together. 5 plus 7 plus 7 is 14 plus 5, which is 19. And so your final answer for this question would just be a 19. So this is a good way to assess whether you know properties of log, but still get a numerical answer. Okay, this next one, remember, we're trying to get everything in terms of 2s and 3s. And so here, when I'm looking at 27, I know that's 3 cubed. And the 4, I know is 2 squared. Okay, and so now when I break these up, I have log b of 3 cubed minus log b of 2 squared. Bring down the 3 as the exponent. Bring down the exponent for the 2. And then now, every time I see log b of 3, and then every time I see, oh, that was blue. Log b of 3, I know that's 7. And I see a log b of 2, I know that's 2. No, 5. And so this problem becomes 3 times 7 minus 2 times 5, which is 21 minus 10, which gives me 11. Okay, for this last one, 72 is 9 times 8, which is 3 times 3, which is 2 times 4, 2 times 2. Okay, and so 72 is 3 squared and then 2 cubed. Okay, so log b of 2 over 3 squared, 2 cubed. And then now when I break this up, log b of 2, and then I would have minus log b of 3 squared minus log b of 2 cubed. Bring down your exponents. And then every time I see log b of 2, I can replace that with a 5. And then every time I see log b of 3, I can replace that with a 7. Okay, so this whole thing simplifies to 5 minus 2 times the 7 minus 3 times the 5, which is 5 minus 14 minus 15, 5 minus 29, which is negative 24.